trying to find out. The meeting is on progress already.
Yeah, okay, so let's start.
Okay, if we are, can you all hear me?
Yeah.
Okay, if you can hear me, I'm going to pray so that all of us will be blessed. Father, in the name of Jesus, the Lord of Lords and King of Kings, creator of heaven and earth, we are here grateful that today we can start more about what you have done. We thank you for those whom you have given the wisdom, the understanding. I pray as they share with us, Lord, bless everyone. And by the time we go home, we all go home knowing we have heard from you and we'll be in a position to take care of the environment you have entrusted to us. In Jesus' name, amen.
Amen.
Okay, you can start.
Thank you. Thank you so much.
Did you hear me? Was I low?
Amen.
Yeah, we
Thank
hear you. Yeah. Thank you so much. Good morning, good evening, good afternoon to you all, distinguished guests, respected speakers, and esteemed participants. Good morning, good afternoon, and good evening to all joining us from different regions of the world. On the behalf of SUNWay Research and Innovation Center and all the partner organizations, it is my great honor and privilege to extend a cordial and warm welcome to all participants to the virtual international webinar World Meteorological Day 2026, started from today, 23rd March, and tomorrow on 24, we are going to in our event. Yeah, well, the program will commence shortly. And also, I'd like to request all the participants to keep your microphone muted during the proceedings. That means when you are not speaking, so that would be great if we mute our mics. Also, use the chat box facility for submitting the questions. And if you have any ideas or like that, our moderator, he will help. The Pastor Ruben is moderating the whole sessions. And kindly ensure that your display name reflects your full name and also the country if possible, by which that makes easier to know who we are and from which country. Yeah. The distinguished dignitaries, respected scholars, honored guests, ladies and gentlemen, it is my great honor and privilege to formally welcome you to the virtual international webinar organized on the occasion of World Meteorological Day 2026 under the auspices of the SUNWay Research and Innovation Center. The observance of World Meteorological Day serves as an important global platform to recognize the indispensable role of meteorology, hydrology, and climate science in safeguarding human life, supporting sustainable development goals, and promoting environmental resilience. This year's official theme is Observing Today, Protecting Tomorrow, underscores the vital significance of systematic observation and scientific understanding of atmospheric and climatic conditions in ensuring a secure and sustainable future for generations to come. Today's distinguished gatherings brings together experts, researchers, educators, and practitioners from diverse backgrounds, united by a shared commitment to advancing meteorological knowledge and climate awareness. Also, let me allow to acknowledge the presence of our distinguished and esteemed participants. Allow me to respectfully recognize our Honorable Chairperson, Professor Dr. Osman, the Director Chancellor of Central Christian University from Malawi. I think he's not available because of the electricity problem. I hope he will join. He will be there. And our esteemed special guest, Professor Dr. Yugoji from US. So he's already here with us. Our all distinguished speakers and our respected moderator, Pastor Ruben from South Africa, our honored welcome remarks speakers, Professor Philip from Trinidad and Tobago, our honored vote of thanks speaker, Ambassador Colette from Trinidad and Tobago and US, and all esteemed participants joining us from various parts of the world. Your gracious presence adds immense value and dignity to this important international observance. It is now my great privilege to invite our welcome remarks speaker, Professor Clyde, to deliver the welcome remarks. Respected Professor Clyde, may I kindly request you to address this gathering. The virtual platform is now yours. Thank you.
Thank you, Chair, for your kind remarks and also inviting me to share some thoughts as such. World Meteorological Day. The theme, observing today, protecting tomorrow. This is a landmark. This is a landmark. And I would like to think it will be an inaugural activity which will set the stage for a series of other things that will be happening, not only on the occasion of this day, but throughout the year. Why am I making this strong statement? You see, we are now living in uncertain times. Uncertain times that is being changed hour by hour. As I speak now, we are quite aware of the challenges that exist in the Northern Hemisphere, vis-a-vis Russia, Ukraine, Israel, the Middle East. We are quite aware. And perhaps, we are not in a position to perhaps have an impact or to perhaps change some of the things that these so-called leaders are causing. However, we are in a position to have an impact as a result of what will be taking place. And I use this word impact because many times one will have seminars, one will have conferences, one will have meetings, and that's the end of it. Nothing else happened. But this conference, this seminar, whatever we call it, is one of change, because we are going to have an impact and takeaway of tomorrow as such. Although I'm speaking from Trinidad and Tobago, but let me put on a regional hat. I am speaking from the region called CALA, and CALA means Caribbean and Latin America. As most people know, that courtesy the President of the United States, he have isolated a number of regions in the world now, including my region as such. And we have been caught, there are some challenges in this region, and I'm sure in some of the speakers here, your region, there are also challenges. And it has been decided that, look, we have to collaborate, we have to harmonize, we have to get together to deal with the fallout that is caused by the geopolitical activities that are taking place. On behalf of CALA and both the academia and industry in CALA, we are going to support activities such as what is happening today as such. We are very pleased that we have a global representation. Global because the listing shows we have representation from Switzerland, from Malawi, from India, Bangladesh, USA, Italy, Romania, Slovakia. So we do have representation. And we are going to say this will be now the voice that will now cause the change that we need, especially for our youths and young people for tomorrow as such. I am due to speak tomorrow on some specific issues as it relates to this program, but I want to essentially congratulate His Excellency Pradeep Sapkota and his team, because I understand that there are other 14 or 12 or so other organizations that get things together. This is great. This is great. This is great. Thank you, sir, and let's have a good opening.
Thank you. Thank you so much, Professor Philip, for your insightful and inspiring opening remarks. Thank you. Now, I'm going to invite, it is now my great privilege to invite our esteemed special guest, Professor Dr. Ugoji, to share her distinguished perspectives and valuable insights to this gathering. Thank you so much. Please, Professor Dr. Ugoji.
Thank you so much. I'd like to first and foremost say a huge thank you, Your Excellency Pradeep, for inviting me and for all the good work that you do. I send greetings to you all, wherever you are on this World Meteorological Day. The overriding theme this year is aptly titled, and I quote, "Observing Today, Protecting Tomorrow," highlighting the essential role of climate, weather, and water monitoring in building a safer and more resilient future and indeed environment. This day focuses on how real-time data from satellites and sensors, and more importantly, weather stations powered forecasting, improved early warning system, enhance safety, and build climate resilience for the future. Distinguished guests and speakers, this important day indeed emphasizes the need for international cooperation and collaboration to share data and strengthen early warning systems to safeguard communities from natural disasters, especially climate change and water disasters. We must not forget, however, developing countries, as they indeed bear the brunt of climate change and environmental disasters. We must ensure that they're not left behind and are indeed partakers in the fourth industrial revolution and not merely bystanders, more particularly in advanced technologies such as early warning systems. Renew Our Earth, an environmental initiative, the vision and mission of which is to empower communities in Africa, the Caribbean, Latin America, and the Pacific small island states to build better, risk-informed communities, rehabilitation communities, strengthen resilience to climate change-related disasters. I wish you all a happy deliberation. I thank you.
Thank you. Thank you so much, Professor Ugoji, for your enlightening and encouraging this address. Your valuable reflection have greatly enriched this session. Now, without delaying, we are going to jump to our distinguished speakers. So it is my pleasure to introduce our first distinguished speaker, Dr. Ivan from Slovakia. He is a nuclear scientist, as well as chairman of Water for Climate Environmental Technology. So now the floor is yours. And the time limit is in between 10 to 15 minutes. So I hope our distinguished speakers will think about the time as well. Thank you so much. Please go on.
Thank you very much for invitation to be participant of this conference. I will turn very quickly to my presentation because time limited is time limited. And I want to say a little bit more. I hope you will see my presentation now.
Yeah.
Is it okay?
Yeah, we see a presentation.
Yeah.
Yeah.
Yeah. So,
Good job.
okay. My presentation will deal with the question about maybe in relation with sustainability, farming or agriculture problem and problem of sustainability environmental. And if we would discuss about these problems in connection with the plants, it's necessary to monitor the entire ecosystem important for plants. It means we need to know important elements of the photosynthesis. If we discuss about photosynthesis, it's necessary to monitor, for example, CO2, carbon dioxide from the air, oxygen from the air, from the atmosphere, water, not only in the air, but content in the soil, and different entities. Some of these elements are like meteorological data, like precipitation, sunlight, CO2 content, but also some external factor which affecting to photosynthesis over time, namely, for example, temperature, pressure, air, humidity, wind strength and direction, temperature, humidity, and water soil matrix potential, which we can call tension. Okay, but we need more monitor the water balance in the ecosystem. We need to know about how much water falls, how much water is in evapotranspiration, how much is absorbed by plants through the roots, how much water transpires into groundwater, and how much water go out by runoff system. For the air function, we can use the different meteorological station. I think it's very good known, but I only repeat that by meteorological station we can monitor wind speed and direction, air humidity, air temperature, global radiation, precipitation, and optional we can add it some soil moisture and soil temperature data. It's useful what we use by meteorological station. But for plants, this very important data, it's tension or water matrix potential in the soil. I would like to show you some new sensor which is allowed to monitor in one sensor soil tension, soil temperature, and volumetric soil content. This tensiometer is refilled by a special polymer. Then this tensiometer is frozen resistant, and they don't need any maintenance. For example, if soil is very dry, he will restart automatically. It means it's different from tensiometer refilled by the water. When after a dry period, you can refill in water again. From this, tensiometer is not necessary.
Professor
For soil
Matusek, could you
moisture,
advance the slides?
sorry?
Oh yeah, Ivan, can you please change your slide because your slides is not changing? Sorry.
Yeah.
Yeah.
It's okay?
Not yet. We are still on
This
your
slide.
we are still on your first page.
He changes to
You lost my screen?
Can you please stop your slide sharing and can you continue again?
Aha, okay.
Yeah, sometime.
Okay.
Can you please share your screen again?
Yeah. It is good now. Can you see?
Yes,
Yes,
now it's
it's
perfect.
Yes,
changing.
we can.
Okay, this is this full range tensiometer which I described. Next slide is sensor for measurement of only for water content in the soil and temperature in the soil, but this sensor is very cheap and very robust and resistant, froze resistant too. And I think it's a very good position for customer who has no big budget for his project. Very interesting sensor is UMP2, which can use for measurement of soil, water soil content and soil temperature. The advantage of this sensor is that it is non-visible on the surface. It can be used under the surface and the battery works 6 months. And the data you can obtain by using only to your mobile phone. So why is necessary to monitor the tension or water matrix potential? Soil keep the water with some power by adhesive power, and the roots sucks this water from the soil with different power too. It means it is some permanent fighting between soil and the roots of the plant for water content. And for example, if you will monitor that soil moisture is 40%, it not means that some of kind of plant is accessible. It means you need the measurement of tension, which show you that which power you need to suck the water from different type of the soil. From, for example, from sandy soil to clay soil, the power is different. And this is very useful if you know this matrix between roots power and power of the soil. You can see very simple tensiometer, which is handle tensiometer, which you can use on different places without some automatic. Okay, what about water balance? Water balance is very special information for you. Because you need information how much water will be divided from the precipitation from the rain to your plants. You can monitor the precipitation volume from the meteorological data. You can calculate about evapotranspiration, and you can measure runoff from the surveys and percolation to the groundwater to like a seepage water. This lysometer content from the soil don't disturb monolith, which have arranged different props like tensiometer, soil moisture, soil temperature, and all these lysometer vessel with this soil monolith is putting on the very sensitive weighting system. You can measure precipitation which starting from 1 milliliter per 1 square meter on the surface. of course, is more scientific, more sophisticated and more complicated equipment, but I'm sorry, it's no time to explain deeper about this. This is the some view of all system. This is the lysimeter. This is the tower with data loggers and every services equipment. And it is possible to install this equipment anywhere in the world because it is independent of power by the using the solar panels and from the different system, because system for data transmission is solved without some necessity of the cables or something. This is the basic scheme how to obtain the data. It means you can use data from different lysimeter from the meteorological station through the data logger. You can send it to the main server, customer main server, and from by wireless possibilities. Then from the customer server, you can distribute this data directly to the users anywhere in the world. I think it's very useful and very modern. Okay, and so I think you will discuss more deeper about data transmission, and now it's possible to data transmission so solve by LoRaWAN system or NB IoT system, and it means this equipment can work really anywhere in the world, in the mountains, in the forest, in the cities. This is the picture how you can use in final the data. Data can be set up that measurement is every 5 minutes during all year. Finally, I would like to repeat the basic system about possibilities for comprehensive monitoring of the plant ecosystem and water balance ecosystem. It means we will obtain the meteorological data from the meteorological station, all function of the air.
Consciousness level. Does that make sense, Brad?
We can measure the different information from the soil, which we need, temperature, tension, and soil moisture. We can measure the water balance between air, plants, and soil and groundwater by lysimeter, and we can add some physiological function of the plant. For example, monitoring of photosynthesis, intensity of photosynthesis, canopy development, leaf mass. We can measure monitoring the transpiration from the root to the leaves by subflow system measurements. Of course, measurement of CO2 and water, and we can monitor the roots by different root health system, root imagery, and it means we are able to monitor all ecosystem of the plants. This is the example how we can present this data for the public or for the students. It's really, we can use the LCD display, for example, on the wall, and trees will answer you if he is good or not good. He has small water content, or he needs the sun. and this is very attractive for children, for example. This system, the name is talking tree system. This talking tree system can be provide like public information, like education system for the students and universities, or for scientists, like talking tree research. So I hope I very briefly I was guide for you what is possible in current technologies and possibilities of technique in the environment. If you have any question or some requirements, how to we can discuss more deeply about some details. If you will send me email, for example, or you will open our website. I'm sorry, I forgot to introduce myself in the invited. My name is Ivan Matušek. I am chairman of NGO Water for Climate, Environmental Technologies, and our organization deal with the role of the water in connection with the global climate change, because we think that this problem is not discussed in so important level as would be necessary. Thank you very much.
Ivan, your first client is in South Africa. You have been following this. You did a good job. So I'll be your first client to bring you here.
Thank you.
Thank you.
Yeah. Okay.
Another second client from Nigeria.
Yeah.
Okay.
Excuse me. Yeah. Well, we have the time slot for the question and answer to our distinguished speakers. So let's wrap up. I mean, let's give the time for another speaker. So at the end, we will ask the questions to all the speakers about your questions. Yeah, I hope you understand what I mean. Yeah, thank you so much. Before we start again, yes, thank you so much, Ivan. What you are doing is exactly relevant that what we are doing here at our Research and Innovation Center with the LoRa, with the sensors. So later on our presentation, I'll also share how we are doing by involving to the youngsters and the farmers from the rural area.
Yeah.
So that is very much relevant to collaborate with Ivan's project altogether. Thank you so much. Without delay,
thank you so much.
Yeah, I would like to invite Dr. Patrick Chiraiu from Romania. He did the PhD in geography, and he's the lecturer at West University of Timisoara. So please, let's welcome Dr. Patrick. The floor is yours. Thank you.
Hello, everyone. Greetings and happy World Meteorological Day.
Wonderful.
We thank you very much for the prayer, because we hope we will not have any internet problems, and so maybe the prayer will help. Okay. My presentation will not be a scientific presentation, more like a presentation which links the human component in the process of acquisition of meteorological data. I will start my presentation. Okay. Just a moment, please. Can you see it? Is it working?
Yes, we see. Yeah, thank you.
Okay, can you hear me clearly?
Perfect. Your voice is perfect. Please go on.
Okay, I'm asking this on and on because we are now right here at the mountain weather station in Romania. in the southern Carpathians, and we are experiencing a very foggy day, and our elevation is around almost 2,200 meters. So we are sitting in a weather station right on the top of a mountain, and that's why I hope for the good network. So I will talk a little bit about the meteorological data, about the processes of acquiring this data, and then I will go to presenting this unique weather station, which, as I said, is very unique because of its location on the top of a high mountain in Romania. Regarding the weather data, why it is important? It has a lot of applications. First of all, we need to know how the weather changes in the future, in the near or in the a little bit more far future. So we need all this detailed weather data for weather forecasting. Then we use it for climate studies, to study climate change, and of course to see if natural hazards can be forecasted. Since the beginning of meteorology, it had also a very strategic importance. Nowadays, it's very useful in agriculture, tourism, urban planning, and so on. I will just enumerate some of the ways we can acquire weather data, starting from the most high above in the sky, the weather satellites, which stand even very far, tens of thousands of kilometers away, or if maybe some of them are really closer in the atmosphere. Sorry?
Okay, please go on. Yeah, please.
Okay. All of these equipments, even if they are ground-based or mounted on satellites or aircraft or ships, they are gathering a large amount of data, and the data is continuously transmitted to the regional centers, and then to national centers, and then all these data fluxes are going to the World Meteorological Organization. So weather data is a very large domain regarding the storing and the handling of this data. So starting from the satellites, they send the geostationary satellites, for example, they send pictures in visible spectrum. Some of them in some sensors are for infrared spectrum, and other, for example, for water vapor. If we go closer on the ground, weather radars are very precise equipments which forecast extreme weather. But this presentation is not so much about sophisticated equipments, but more about how humans are engaged in acquisition of weather data. And on the ground around the world, there are approximately 11,000 weather stations which work simultaneously and which transmit data continuously to the World Meteorological Organization. So I will speak a little bit about this specific place where I have been working for 5 years, and which is very, very interesting because, first of all, it's really isolated. It's located on the peak of the mountain, and you have to get there on foot. It's a long way. We have to walk 4 to 5 hours. It's the most isolated weather station in Eastern Europe. The shifts here are very interesting. When we arrive at the station, we usually stay here 2 people, and the shift lasts at least for 2 weeks. So we are isolated here and we're just observing weather and transmitting data. What do we measure? Like Ivan said earlier, the characteristic, the typical weather parameters like air temperature, precipitation, wind speed, humidity, pressure, radiation, and characteristics of snow. But actually all this information are recorded by automatic sensors. So the tasks of the meteorologists are much easier now. We don't have to measure physically all these variables, but the automatic weather station does it for us and sends it via internet to an app which we have here in the office, and so we can concentrate on observing the weather patterns. What we observe, mainly information about clouds, visibility, cloud types, and all kinds of weather phenomena which occur. The most interesting thing is maybe the way up. You can see in this picture the exact location of the station. The road is sometimes tricky. Sometimes people get injured, and there were also cases of meteorologists which lost their lives here trying to get to the station. So the human component is very important if you have this type of environment. But as long as we get safe here, then everything gets quiet around and in your head, and you just do your job. You observe the weather and try to be quiet and to be respectful, because I think this is a privilege to work here and to get the chance to stay a lot of time in solitude and focusing on what's important. So we experience all kinds of weather. We have different things to do. For example, in summer we chop wood. In winter we have to manage the instruments so they still work continuously. And of course, we have some other partners here which make our life even sweeter. So basically, this is what I wanted to share. A specific case of, let's say, a romantic weather station where people work. This job is more like a way of living than an actual job. Thank you very much for your attention, and I hope you heard me clearly.
Thank you. Thank you so much, Patrick. Really, we are feeling like we are in the high mountain together with you. Thank you so much by bringing us over there. I'm sure we all have the questions, I'm sure. So yeah, we have the time later on. Yeah, well, also we have, now we have our chairperson, Professor Osman. He is here now. He's the president, chancellor of the Central Christian University from Malawi. So let's welcome him.
All the way from Malawi.
Yeah, from Malawi. Yeah. After the presentation, he will have the time for the remarks as well. Yeah. So to be continued, I'd like to invite another distinguished speaker who is an inventor, Richard Nelson from Canada. So let's welcome him. Please, the floor is yours now. Richard Nelson, thank you.
Well, it's really great to be with you today, and I guess, you know, as some of the introduction already speakers have said, that our consciousness is focused on our time in history and the you know, the really dynamic situations that we're facing. My focus has been on how to equip families and communities with food security. And essentially, it does come down to climate, and what I'm putting together is a climate adaptation solutions. And so the requirement is that we have a closed and controlled ecological environment. And what this is basically a regenerative system. Um, this is a long history of development that includes the space programs, and it is previously studied as also from the NASA programs, uh, closed ecological life support systems. So what we do is mimic nature. And you need to create a complete ecosystem to achieve this. And you need the five kingdoms of life, basically. So, we're all aware that, we need to get these circular systems, which include the water, the nutrients, the carbon, oxygen, and find an equilibrium with temperature, relative humidity within the controlled environment, all of these technical issues. And the most important probably really is the sun, the source of light. Without the photons, we don't get plant growth. We don't get life. So what we're doing, of course, is focusing on using natural sunlight. This is not a science project. This is a low-tech outcome. We call it Life Pod and Life Farm. And what we're doing is bringing this kind of high science, combining it with a low-tech, and making that accessible to families. So it's been a long journey to that. And as part of that process, I rather gave up basically on the industrial uh, sector as being receptive, because when we can all grow our own food in our backyard and it is regenerative and our costs are nil, practically speaking, except for the capital cost, of course, um, that means the consumer becomes a producer, and it changes everything. So, and we want to do this throughout the world in open source. My several patents are dedicated to open source use. And uh, the time that it's taken has also been part of that process of eliminating the non-responsive, communities or sectors, and finding those that really want the technology. And so we have a network of early adopters, and even this year, so it's really great that we're having this talk today, that we'll have the open source, fabrication and how to build such a life pod. Um, it's a small space, it's 5 by 5 meters. So yes, it can fit in most backyards and most places. Um, it is also taller though than it is, in terms of the footprint. And so we're teaching, as I said, the five kingdoms of life. Fish are animal kingdom.
Excuse me, Richard, are you sharing your slide? But we didn't.
Oh, no,
Yeah.
I
Sorry.
didn't really put together a slide, but I can perhaps I can share this one. Let's try it.
That would be much more interesting. Yeah.
Yeah, yeah. Okay, so these are the life pod itself, and I guess I can show you what they look like here. I guess I have to go to the actual. Oh yeah, I'm in SketchUp. Okay, I better camera just zoom a little here. So yeah, and this is this is the pod here, and you can see that it's an interesting geometry. You can walk inside there. Maybe I should zoom in some more. Yeah, there we go. So yeah, and it's a very what we've done is we've dematerialized. I believe in this very much. That we can make this quite a low cost structure, and it's basically a tent structure. So I think just rather than go into the technology here, but one thing you can see, it's kind of egg-shaped. Okay, it's from this view, yeah, and from this view, of course, is the proper structural design view where you see the arches. Simple construction, but this is the actual shape of the space inside. And what we have here, the cover materials, are a single curvature, so we can do it with semi-rigid materials and tent materials, and of course transparency is the key. But what you have is an inner space and an outer cover, as you can see. And what we're doing is we fill this space. You can see this on our website. I put up my contact details with the website. But this cavity space is the key. This is where we have the use of water. Below, underground here, there is a fish tank. I suppose maybe I could, yeah. Anyway, I think we won't get bogged down in the details. The critical thing here is that it is a system that is vertical with fish below and the green above here. And what we do is this cavity is controlling the environment very much like climate. What we have here is water in this space. Now, there's two ways. We flow a thin film of water over this inner cover so that the space inside, the climate is controlled by liquid cooling. Okay, there's no ventilation required, and even the hottest climates. The secondary system is that we use that same soapy water. By the way, it has soap in it as a surfactant. And we use that same water. It is stored in its own reservoir here. And we generate bubbles. It's a mass or blanket, or you could call it a cloud of bubbles. It's a foam. It's a liquid foam, water-based, of course, so it's not permanent, but within the cavity, as the cavity is a sealed space, the bubbles last a long time. So what you have is an insulation, and it turns out that it's a super insulation, so that we can get to R20s to R40s with this device. Also, it's extremely low energy. It's extremely simple. So basically, we're using water to fight the climate. We're not so much fighting nature, though, as working with nature. The plants which are inside on these different levels are transpiring and cooling, and we're condensing all of that transpired moisture and controlling the temperature with our liquid cooling process. So overnight, we radiate that same energy. So there is a small diurnal cycle on the total thermal mass. And thermal mass is the quantity required to get through a hottest day in the UAE. We're doing this in China. We're doing this in several countries right now. And here in Canada, we'll be also having a unit. So it is open source. We're doing it publicly. We're publishing to the internet the data. And what we're proving is that you need well, it's a 50 times reduction in a COP of coefficient of performance is 50. So yes, there are parasitic loads to the system. It's basically solar, But the loads are the bubble blowing, which takes 5 minutes and lasts then hours, and the liquid circulation, thin film pumping, which is less than 500 watts. So it is a very low energy process for a result which is basically air conditioning, but in many ways is better than air conditioning because we're also controlling the relative humidity inside at a steady state. So we're really mimicking what nature does because, you know, plants and forests cool the continents. If you don't have the plants doing the cooling, you have a desert like the Sahara. And of course, also the evapotranspiration of the forest draw the humid weather patterns inland and regenerate water. That's called the green water cycle. So yes, there is a strong connection here to our understanding of climate, and indeed the soap bubbles foam replicates the spectrum of what comes through cloud cover. So you could think of this as an artificial cloud cover in the arid lands, and it is an insulation also that has no thermal lag. It has no heat capacitance. In effect, it is a controlled temperature always, so your enclosure never becomes hot. You know, when we have to air condition, it's because our buildings heat up in the day and then they take time to cool down overnight. This is the process of air conditioning. You're working to control your building temperature, not your inner climate. The inner climate has almost no thermal capacity except what's in the water. So water is always the key. We dematerialize the building. This is the opposite, let's say, of massive passive construction. And we also utilize all of the solar energy because, first of all, we're using that solar energy for the thermodynamic stability, climate control, heating, cooling. Secondarily, we get photosynthesis, which is then, of course, food and energy, because we have the bacteria for the generation of the biogas and from our biomass. So we regenerate the energy. This is all was uh, basically solved problems in the 1990s by programs like the NASA CELS program. I was an observer from Canada in that program. Um, but so, like organic and other technologies that are natural, where you don't need the synthetic inputs, they're neglected. These are neglected sciences and technologies. So I will be aiming to see universities, schools. We have schools in Nigeria. We have schools around the world that are looking at installing these because they're not expensive and you can do a lot of life science. So everyone interested in the STEM programs, I once connected with people in Trinidad and Tobago there, but I'm sure we'll see one of these in Nepal soon with Pradeep. And of course, as I say, it's open. I think I'll leave it there. I must have gone over my time probably. So yeah, just about. So thank you.
Good job.
Thank you so much, respected Richard Nelsons, for your great invention. And I hope, yeah, we will achieve, because as you mentioned, it is the low cost and also easier to invent by using the local resources. So I'm sure with all the distinguished, respected participants here, yeah, we will make it happen very soon under your leadership and also through other joining hands. Thank you so much.
Maybe I'll just say one more thing. We call it also the heat shield. So we call it the heat shield of abundance. And indeed, even this summer, we're going to find again heat waves that are very difficult.
The charger.
Yeah.
Switching off.
Yeah, also we have the questions to our speakers. So I hope the participants will write the questions on your paper. So after our presenters' speech, yeah, we will open the floor, yeah, for the questions. Now I would like to invite. Scientist Dr. Akhilesh from India. So he's the chairman for Asardeep Group of Companies. And I'm going to share his presentation slides through my screen. Yeah, please welcome Dr. Akhilesh. Your mic is muted. Can you please unmute? You are muted. Yes, now.
Yeah. Thank you. Thank you, Mr. Pradeep Subkota. It's very nice to be here, and very warm welcome to all the scientists, engineers, other players across the world. We are here on we're talking about the climate change, the use of meteorological data globally, the advancement of it. So myself, Dr. Akhilesh, and my topic is impact of climate change on weather patterns, as well as advances in meteorological data collections. Okay, professionally, I'm a scientist. From last 17 years, we are into business. We have a multinational organization, as well as research and development center also. My own have couple of inventions. Something is going on around 163 inventions we have right now, as well as a couple of books we write, from science to advancement of the society, and so many other topics, like from spirituality and on Himalayas, like this. Okay.
Okay, can you see my
So
screen?
yeah, it's very nice. It's
okay.
very nice.
Okay, welcome.
So we can proceed it with our topic. The next slide, please. We're talking about the introduction and what is going on across the world about the climate changes and how we understand it through meteorological data. There are three ways to understand uh, the global climatic changes through meteorological data. Its first one is the weather patterns and the data revolution, what we are getting and collecting. Okay. Second, understanding the impact through advanced meteorological tools. Now we have very modernized, we have very advanced technologies with us, by which we can get the data, or the futuristic data also. Means what is going on, like earthquake, we get to know sometimes earlier, or any kind of flood or tsunami, we know it in couple of days. These things are happening. Okay. And the third one is relevant images showing extreme weather events, like cyclone or droughts or flood. Next slide, please. The second, the climate changes, basically why and how it is growing day by day, and what are the basic causes of it, why we get rid of it. It's very important because scientists have very important and crucial role for the society. It's very important that we must have to know what is good or bad for the society, what is bad for the society, either after the development also, after the invention also. We have to stop it unless it will destroy the complete society. Like you see, COVID impact, we saw it. It is one development, and that will destroy millions and millions of life across the world. Okay. So climate changes basically, there are few certain points that is rise in global temperature. It will rise 1.1 degree since its pre-industrial era. Means if you're talking about last 70 years, so Earth temperature increases 1.1%. It's a very dangerous sign. It's a very dangerous sign. When it crosses 1.5 or 2, uh, people cannot imagine what worst is going to be happen in the world. Second one, increase greenhouse gases like CO2. It's very high these days, 415 ppm. Another very crucial things happened on Earth is melting polar ices caps and glaciers. Okay, due to increase in temperature, you see that only 1.1 degree increase in temperature, 20% of polar ice will melt. We all know about the Antarctica condition, what is going on over there. Uh, and what is the impact we are getting it out of it? Altered atmospheric conditions and extreme weather events. We see across the globe, we saw it across the globe, floods, earthquakes, volcanoes, everywhere in last 20 to 25 years or 30 years. It shoot up like anything after 1990s or 95. Next slide, please. And how it impact on climate change or weather patterns. Okay, uh, we talk about the global temperature rises. This is 1.1 degree. Another extreme weather events, heat waves. We take example of India. We saw it that India, that heat waves increases 50% in last 15 years only. Okay, when we are talking about 2010 to 2025, and when we compare it to 80s to 90s, it will increases 50%. Okay, last year we saw many cases in India. People died when they come out from the car. They die in a fraction of few seconds, hardly 50, 60 seconds. Cyclones, 4 point cyclones, North India ocean cyclones intensity will increases by 21% from 1970 to 2025. Floods increase like anything. We have many cases. 2012 13 Kedarnath tragedy happened. uh, Kerala tragedy happened in Bihar. These are few states in India where floods comes very fast, and its intensity was very huge. India's average annual flood damage is more than 90,000 crores. It's more than 10 billion USD approx. Okay. That will happen between 2010 and 25. It's a ratio I'm talking about only in 15 years. See the situation. Next slide, please. When we are talking about the annual mean temperature, next slide. Mr. Pradeep, next slide, please.
It is not refreshing. Just a second.
Okay.
Let me stop and share again.
We are talking about annual mean temperature. We are discussing that will increasing year to year. We will discuss about this from 1950s to 2025. In 1950s, it is normally 0.2 percent. Later on, it in 80s, it is going to be normal. Again, in 2000, it increases to 0.4%. In 2020, it increases to 1.1. That is the data we'll get it from Indian Meteorological Department as well as NASA JSS. monsoon rainfall, the yearly rainfall is decreases 12%. In some cities or some places, you visit or you see the data, like in Delhi or nearby Delhi area, and wherever we cut down the trees, rainfall decreases like anything. Okay, this data 12% is between 1951 to 2025. In 75 years, if rainfall decreases by 12%, so these are very dangerous sign for all of us. We must have to understand how to increase and how to neutralize these system, and what are the techniques, tools we have to use to stop. Sea level, India is connected with sea from three of his areas, in east, in west, and south. Okay, so only in Mumbai, 1.2 mm per year sea level rises. The similar situation, if the similar situation going on, half of the Mumbai is over in next 15 to 20 years. Next slide, please. Yeah, just a minute. Last slide. Advancement in meteorological data. What are the advanced technology we will get it nowadays, and how we can utilize is, and what is the advantage of it, and we get the forecast data very easily, but we have to take proper precautions, and for the long term we have to utilize or implement proper techniques and processes for that. When we are talking about the technologies, satellite is, we get it real imaginary data these days, real time monitoring from, for example, from INSAT, 3D, NASA, Terra. From these are the processes by which we get the exact data. Doppler radar system, accurate. It is almost 99% plus accurate forecasting. They can very easily track cyclones. Weather stations, we have very good weather stations. We listen from one scientist who was posted in Romania somewhere in high hills. Okay, ground level data collections, AI and machine learning. AI is very useful in this scientific works, but not for the public. We know it very well. We can, what is the impact of it? We have all these data, but what is the impact? Improved forecasting accuracy for cyclones, floods, and warnings. We easily get warning. We can give it to public. They can save themselves. And better disaster management and planning is required to implement. Next slide, please. Impact on weather patterns. Okay. What are the impacts on weather patterns? We'll get it. Like at extreme events, increased frequency and intensity of heat waves, storms, and floods. Okay, these are very extreme events. Erratic monsoon affecting agriculture, like agriculture is very drastically change. So in that case, these weather patterns will save our farming. Then regional variations. When we are talking about the regional variations, the rising sea levels and cyclone, it is in the coastal cities. Okay. In Himalayas, when we are talking about the Himalayas, north part of India, glacial melts and floods. A very big incident happened in 2012 and 12-13, both 2 years, where millions of people lost their life. Okay. Next slide, please. Next one. Impact of global climate change on weather patterns. Okay, there are a few basic points we have to understand. Extreme weather events like increased frequency and intensity of heat waves, storms, and floods. We saw it very clearly. Very friendly or eco-friendly cities, humans were destroy those cities, cutting plants, trees, and we make a concrete buildings everywhere. Very good examples, you saw it, Delhi, Mumbai, uh, in top-notch countries like in New York, uh, are the best examples where we cut all trees and just concrete buildings we structured over there, we build over there. Okay. Erratic monsoons affecting agriculture, because whenever monsoon will disturb, that will directly make a very bad impact on farming and agriculture. Okay. Again, we saw at the regional variations, the coastal cities, like rising sea levels, cyclones in Himalayas, Galactic melt and flood. In global trends, when we are talking, the increase of temperature, it's very dangerous and very painful for everybody. A lot of people's lost their life because of this very small issues at the global level. We saw it, but when we are talking about the impact of it, it's very huge. uh, General WHO data we collected a couple of years back in 2023. Because of the nature impact or nature's effect, average 1% people were died every year. Okay. Sea level rising at 3.2 millimeter per year. That is the data of 2018 to 25 at a global level. Okay. How it impact to other countries? If you're talking about the continents, next slide, please. Continent-wise data and its impact. Here's a breakdown of continental-wise climate change impacts. First of all, we see it in Asia. The sea level rises like anything. Okay, that will make a very big impact on the population, coastal population. 63 million people at risk from 100 years of flood. In last 100 years of flood, 63 million people, you just see the data. Impact economic losses projected at 167.6 billion. That will increase 0.47 million rise every year. 70% of exports population in Bangladesh, China, India, Indonesia, Japan, Vietnam, the southeast countries were very badly affected by this. Next, we are talking about the African continent. There are rising factors than global average, with Western Indian Ocean experience of 3.88 millimeter per year. Okay. Impact 54.2 million people in low elevation coastal zones. Potential displacement of 750,000 in East Africa by 2050. See the situation in Africa, because of only deforestation, these problems we are getting it. Okay. Next, we are talking about Europe. Europe is majority of Europe is dry land, but in coastal countries we are talking about that erosion effective sandy coastlines like Spain, Italy, Portugal, Denmark. These are very important cities of important countries of Europe. They will get direct impact of this weather pattern. Like a very big example, we have Venice is sinking like anything. France faces potential displacement of 8,000 to 10,000 people by 2080. In a similar way, next three more continents we have. North America, US East Coast rising 3 to 4 times global average. It's very high. Miami and New York City, you check it out. Many cases already happened. 4.2 million people at risk and 0.9 meter rise in water level that will completely damage the California's GDP. Again, we come to South America. Coastal flooding and erosion affect 3 to 4 million people by 2100. It's less because of this less development of South America, or the population is very less over there. Guyana, Suriname, Venezuela coast population is at very risk. They are at a very risk stage these days. Okay, Guyana already going down below the sea level. Australia and Oceania, we are talking the islands which are nearby Australia.
Yeah,
There's
excuse
a
me,
sea
please.
level.
Because of the timing, could you please a bit do in a brief? Sorry, thank you.
Sure. 0.2 to 0.3 meter likely by 2050. And that will make a very big impact on Queensland Sunshine Coast tourism. Okay. It will impact 12.75 billion worth of building exposed. Okay. Antarctica, the glacier is going melting like anything. Next slide, please. The case study of the Indian monsoon trends delayed onset, intense rainfall. Okay. Uttarakhand, I just give you an example in 12-13 flood, Kerala 18 droughts to 15. Okay. These datas we can improve forecasting models to save the lives of the people. Next slide, please. A conclusion, advanced data tools help predict and mitigate climate impacts. Action point is very important, where the first role start of from a scientist, then the people who are working at the ground level, the government. Plantation is very important. Since 2024, we started plantation drive in 11 countries, and almost 8 crores uh, means 1 million, sorry, 8 million plantation we did it in last 2 years. Water conservation is very important. Soil conservation is very important. Humans must have to keep nature in a natural form. Don't try to change it, like use of manure in place of artificial manures, use organic manures. Alternate energy, every scientist we are talking about alternate energy. I'm a scientist, solar scientist already, so we know the impact and the possibilities and the betterment of implementing of these alternate energy, solar, wind, biomass. These are ultimate, just you use it, utilize it. And if you want any kind of support or help, we are providing it. We are already present in 42 countries of the world. You can visit our YouTube channel and Instagram channel also. So you got a lot of data. We have a research and development center. So continuously from last 17 years we are working. Next slide, please. Thank you, all of you. If you have any query, you can ask or you can email also to our center. They will reply you in a brief, and whatever the supports you needed, and also whatever supports we needed to save the world, to save the environment, save the nature, always welcome. Thank you, all of you.
Thank you.
I think we can do the questions a little bit later. Let's get other speakers.
Yeah, thank you so much, Dr. Eccles. Definitely, we will collaborate with your research center, research and innovation department, along with our research and innovation center. So after this event, of course, also, who knows, we can meet together. Mostly welcome either in Nepal or India. Yeah, thank you. Okay.
Welcome,
Yeah,
all.
yeah, thank you. Okay, now we have another technocrats. Very interesting, distinguished speaker from Switzerland, Markus Luther. He is the co-founder, CEO, and CTO of Make Human Technology. So his topic is on about air quality monitoring. So please welcome. Let's welcome Markus. The floor is yours. Thank you.
Thank you very much. Can everyone hear me? All right.
Yes.
Yeah.
Very good. So let's start. Oh, let's start the timer too, so that I don't overrun. All right. So Pradeep already said, co-founder, CVO, and CTO of Make Human Technology and participative environmental technology in Winterthur, Switzerland. Pilot in training, future commander. We'll get into that later. Founder and builder. Hardware, firmware, citizen science, OpenSIM, software, everything. So what do we do 20,000 times a day without thinking? Breathe, more essential than eating or drinking. And if you think of Switzerland, then you probably think of precision watches and clean water and a highly developed industrial nation. And you would assume the air is safe, but it's not. So like Winterthur, where I am at the moment, Winterthur is classified as an air quality remediation zone. And we don't know where the bad air is. There is one sensor for the whole city of 116,000 residents, one. So the rest is modeled, an approximation, it's heavily distorted, and it's blind to local hotspots. The fixed stations give you points, but no map and no truth. So what do? We said, let's take a whale and a remora. If you don't know what a remora is, it's like a fish that clamps to the whale. They just suck up to it and then they travel with it. So the whale is in our case Stadtbus Winterthur, which means that 50 electric trolley buses going through all the city all the time. Like I think all the lines, I think every 2 minutes or so a bus stops somewhere in the whole city. And they already support our project. And then the remora, the fish, is our sensor. It's non-invasive, so it just travels on the bus. It's self-powered, solar, and it has no connection to the bus. So what are we doing at the moment? We will place 1 to 3 sensors on trolley buses as a pilot to see if it works. We also have 3 fixed sensors at IMPOT. That's like the scientific station of Switzerland research. And then we also add 3 sensors next to the official 1 sensor so that we can get the scientific reference. So basically, when we then measure mobile measurements, we have calibrated and scientific verified data collection. Let me check how I am in time. 11 minutes. So what do we do? Or what is the special thing about us? So it's hyper-local. Because every 2 minutes, a bus is driving, I don't know, maybe 300 meters and then stopping again. So we have hyper-local data and not modeled. And it's 4-dimensional because it not only contains the geographic data, but also the time data. It's radically cheaper. I think the current sensor is around 200 francs, Swiss francs. Because normal fixed monitoring stations are around 5 figures, Swiss francs. So it's radically cheaper. Everything is open source, so you can replicate it. Everything is open data. There is no owner. It belongs to everyone around the world. Then you can add schools at nodes for those sensors, but you can also have schools building the sensors, DIY. So you have STEM inspiration, but also awareness about air quality from an early age. And as I said, it's non-invasive. They're autonomous sensors, no modification to the bus. So what could that mean beyond winter tour? Any city with public transit? Any? Kathmandu, Nairobi, Geneva, Zurich, who knows? Open data for everyone, no proprietary lock-in, governments, researchers, citizens, same data, open, everything. And schools can be the network too. Students build the sensors and then communities own the data. And then you have citizens doing science. If you want to see a demo, there is an URL back there. So next. And then maybe a question, who pays for our sensors in Nairobi or in Kathmandu or who knows where? So the bare bones sensor is probably around 70 Swiss francs. You have to convert that to your local currency. That's the hardware cost. And outdoor probably 120 francs, Swiss francs. That's hardware cost per unit. Maybe there is an NGO or sponsorship by the city, maybe. The schematics, firmware, enclosure, everything is fully open source, fully, 100%. Schools can build them because there is no factory needed. Basically, you need students and you can not even soldering needed or not much. Maybe one cable could be soldered. And then you can see if there are any local universities or partners, like I said, NGOs. Basically, we in Winterthur do the blueprint. We say, okay, it works. And then others like you or anyone else can replicate it because it works and is scientifically proved. Let me check the time. 8 minutes. Okay, I'm good. So now you can think what an air quality sensor could do for your country. So you can send me an email, explore the live data, think like in your country, in your city, in your neighborhood, in your community, how that could improve. For example, in Winterthur, they're thinking about, you have cars bringing the school kids to school, which is not good because then you pollute the air. So you look, where is the best air to walk for the kids, for example, and then you use the police to chase away the cars. So as I said, open source, open data, no owner. We are funded by the city itself. So now the interesting part, and also where Pradeep has something to say or is part. So the vision is we never own the infrastructure, we just ride on the infrastructure, like the buses. We don't own the buses, the city does. Same with the building. If it's a high rise or a school, we don't own it, no problem. So if we scale that up, if you scale it up, stay small, go everywhere, we just take a SpaceX transporter and put up 120 satellites that we can build DIY. And then I will also go there myself to space with Pradeep. So I'm the commander. Pradeep is the mission specialist. We have one open slot for someone from, who knows, maybe a student from Africa or Asia. We also bring one robot with us. So, Pradeep, are you ready for this mission?
Yeah, definitely we'll do that. And also, yeah, thank you. And also, can you please show your device, how you
Yes, of course.
monitor your
We
quality?
have 6
your
minutes.
quality. Yeah, you have still time, 6 minutes. Yeah, please.
So let me, here is the website, inspiration5.ch. Here is the mission badge. Then we have all the slots. We have the open slot. So you can check it out. So, Freigabe stoppen. Oh, no, actually, let me share it again so you can still see it. I'll keep it open. So here's the device. Oh, let me switch off the video. Where is the video? Here you go. So here's the device that you can see how big it is or how small. See it?
Can you please stop your screen so we can see? Because
Oh,
still
okay.
your screen is sharing, so that's why.
Ah, I see.
Yeah, now
Now I
please.
can see.
Yeah,
Ah,
you can show,
so
yeah.
that's the size. Then I open it up. Right now it looks like a jumble of wires, but it's actually working. Solar panel, sensors. It uses LoRa, of course. So it works everywhere. It has a battery, so it's autonomous. It's waterproof. What else does it have? Low power. It has all this. It has all the data that you need. Oh, here's the sensor. Let me grab it.
Yeah. So what is this sensor to monitor the air quality?
Yeah, Sensirion from Switzerland. SCN66, so NOx, PM, temperature, humidity, I don't know what else, VOC, like everything in one.
Yeah.
Quite cool.
Great.
I think that's about it. 3 minutes for questions.
Yeah, we have the 3 minutes if we have the questions. Yeah, if not, then we will ask the questions later on because we have still three speakers remaining. So that's why. Shall we jump to give the time slot for the speaker, and then we will ask the questions to all the distinguished speakers. Yeah, thank you so much. Now we have another distinguished speaker from Romania. His name is Losif, and he is the GIS and remote sensing expert. So his topic is on the cloud seeding and crop protection. Let's welcome him. Yeah, please, the floor is yours. Thank you.
Thank you too, Mr. One moment to share my screen. Can you see my presentation?
Yeah.
Yes.
Yes.
All right.
Yeah, and I hope you will manage in a time. Thank you. Yeah.
Yeah, sure. Good afternoon from Romania. My name is Iosif, and in this presentation, I will discuss about cloud seeding with a particular focus on hail suppression and crop protection. The aim is to show with this system operates in practice from national scale organization to real-time radar analysis and seeding cloud decisions. This map shows the national hail suppression system in Romania. The blue points represent hail suppression rocket launch points that are currently operational, while the red points that are still under development. What this map clearly shows is that hail suppression in Romania is implemented as a coordinated national system rather than as an isolated local intervention. It also highlights the territorial expansion of the network and its role in reducing hail-related damage in agricultural regions. This slide highlights the territorial scale of the hail suppression system in Romania. Right now, the system protects about 25,000 square kilometers, meaning that nearly 1/5 of Romania's agricultural land is already included within the protected area. This is important because it already shows that hail suppression is not a marginal activity but a significant component of agricultural protection at national level. Also, this map shows the operational hail protection network in Timish County. The black circles represent the 12 hail suppression rocket launch points distributed across the county. These sites are activated whenever meteorological conditions indicate a significant hail risk. The entire activity is coordinated from Timișoara, the biggest city in the western part of Romania, where the command center is located. This is where the weather condition is monitored in real time and where launch decisions are made, including if intervention is necessary, how many hail suppression rockets should be used, and the technical firing parameters such as azimuth or elevation. Another important feature of this map is that it shows the dominant land use categories within the protected areas. Most of the covered areas consist of agricultural land. For this reason, the network is designed not only to cover a large agricultural area, but also to protect high-value crop such as like vineyards. Here we have explained the basic mechanism of hail suppression. Hail suppression rockets release silver iodide into cumulonimbus clouds, where it promotes the formation of many small ice crystals. The objective is not to eliminate the storm itself because it's impossible, but to influence cloud microphysics in such a way that the formation of large hailstones becomes less likely, let's say. In particular terms, the entire process aims to reduce the probability to large and destructive hailstones will develop inside the storm. Instead, the goal is to favor the formation of smaller frozen particles or precipitation that is less damaging when it reaches the ground. This is why hail suppression is directly linked to crop protection. In hail suppression rocket operations, we use data provided by the meteorological radar located in Timișoara, with updates available every 5 minutes. Using specialized radar software, we generate multiple cross-section through the cloud, which allow us to identify the speed of convective cells with hail potential, their distance from the protected area, their direction of approach, and of course, their direction of movement. Also, the software allow us to evaluate key storm cells parameters, including liquid water content, vertical development, internal structure, and hail severity potential. This assessment is based primarily on radar reflectivity expressed in dBz. Cloud reflectivity is a radar-based measure of how strongly cloud particles, such as raindrops, ice crystals, or hail, reflect the radar signal back to the antenna. A higher reflectivity usually indicates larger or more concentrated particles inside the cloud. In operational terms, high reflectivity values, particularly above 45 dBz, are generally associated with large concentration of supercooled water and growing ice hydrometeors within the cumulonimbus cloud, indicating an increased probability of hail development. Once the parameters have been established, the target sector of the cloud to be seeded with silver iodide is selected. Silver iodide, the active agent contained in hail suppression rocket, is dispersed then into the designed seeding area. The software then indicates the number of rockets required for effective interventions. Following seeding, the need for an additional intervention is assessed on the basis of the subsequent evolution of radar reflectivity. And the overall trend of the storm cell's parameters, whether intensifying or weakening, all operational decisions are made in real time and must be executed without delay. This is so important. To ensure that the intervention achieves its intended effect and remains operationally effective, the entire process of analysis and decision making, including whether further rocket firing is required and which sector should be targeted, the entire process should take no more than 2 minutes. This image helps explain why silver iodide is used as the active seeding agent in hail suppression operations. The crystalline structure of silver iodide is similar to that of ice, which allows it to act as an efficient ice-forming nucleus in cold cloud regions. From an operational point of view, this is important because the intervention depends on introducing particles that can support the formation of many small ice crystals inside the cloud. In this way, the seeding process helps limit the growth of large hailstones and support the objective of reducing hail-related damage at the ground surface. Here we have a schematic vertical cross-section of a developed cumulonimbus cloud and the associated seeding sectors. First zone corresponds to the seeding sector of the convective cell during the incipient stage of development, with the aim of promoting early precipitation formation, while zone 2 corresponds to the reagent dispersion sector intended to suppress the development of large hailstones. The figure is important because it shows that cloud seeding is not applied randomly. On the contrary, the intervention is spatially targeted according to the internal structure of the storm and the specific objective of the operation. In conclusion, hail suppression in Romania should be understood as a coordination operational system designed to reduce hail-related damage in agricultural areas. Its effectiveness depends on continuous radar monitoring, fast decision-making, accurate targeting of convective cells, and a clear understanding of cloud microphysics. The use of silver iodide aims to influence the internal development of cumulonimbus clouds in such a way that the formation of large hailstones become less likely. Overall, this system represents an important component of agricultural risk management in Romania. Thank you for your attention.
Fantastic. Thank you so much for the really the great and practical, the actionable activities where we need such kind of the technology everywhere. Just for example,
Yes.
when I was in Kenya in Marsabit, they have really the drought. Also in Nepal, of course, in most of the part of the countries. And if we succeed to adapt those kind of technology in collaboration with Losip and his team, that would be really great. And also, I already seen the chat. We can also consult with the embassy or maybe with some stakeholders. That would be really great.
Yeah.
We will definitely collaborate with all together. So yeah, also we have another second last speaker. I'd like to invite Professor Mauro from Italy. He is the Global Pro Vice Chancellor of Next Gen University International US, and also he is an international wine educator. So he is going to explain on about how the metrology is really the factor, one of the factor for the wine educator and also in the university research and development. Please, let's welcome Professor Mauro from Italy.
Oh, thank you. Wonderful. You are welcome. It's a pleasure. Good day and heartfelt greetings to all of you. And special thanks to you, His Excellency, to Pradeep, a great friend, a great human being from my point of view. Okay, I wish to introduce myself briefly because my speech is around 9 minutes without presentation. I'm Mauro Virginio Polticchia from Italy, and as a seasoned board member, keynote speaker, and food and beverage and wine expert, I have a privilege of really a rich tapestry of experience across various domains, from academia and business to civic engagement and beyond. Today, I'm here, as I said before, as a Global Pro Vice Chancellor of Next Gen University, International University. My pillars are always the same, and I'm happy to share here them because I think that they are aligned with these prestigious events. So ethics, integrity through credibility, innovation. I think that these are really important pillars. Okay, we can start. Okay, it's clear that meteorology has a concrete impact on everyday life. You know, it's not a niche matter. It's a matter that connects to many other sectors, from land transport to air transport, from earth minerals to sources, and many others. Agriculture in this stage is one of the most important. From this assumption, we implemented in the new concept of study, really a degree. In the key of my speech is to present and share a new department, starting from my expertise, starting from my experience as a wine educator, that will be launched during next academic year through our institution. The sustainable wine growing and enology as a specific field of study. Why? Because the global wine business is approximately 500 billion industry, 500 billion industry. So it's a huge market. Many challenges and transformation are going. Okay, it's crucial to have a new vision from my point of view and approach this field at 360 degrees vision. We have to keep in mind that agriculture is strictly linked with the technology, with innovation, and with the meteorology as consequence. It builds on wine growing and enology background by combining cutting-edge topics and the technology like adaptation to climate change, digital and precision wine growing, and enology, soil health and management, new meteorological approaches with sustainability practices across the wine value chain. Our method is innovative through labs, experimental project, and field visit, a complete path to generate a thesis-driven research project with a department research group. Wine is a big part of the human culture for millennia, blending tradition, agriculture, and science into a single refined craft. As the global wine industry faces complex challenges from climate change to environmental degradation, there is a growing need to innovative and sustainable solutions. You know, here meteorology is a really important key, as I linked, as previous mentioned. Obtain a deep knowledge in sustainable viticulture and enology offer to opportunity to combine a passion for the wine with a cutting-edge science and environmental stewardship. This field is not just about producing high quality level of wine. It's about ensuring the wineries and wine production remain viable and environmentally responsible for the future generation. If you consider a future in the wine, agriculture, food and beverage industry, here are the key reasons why a path of study in sustainable viticulture and enology could be the perfect choice. So the key are simple like following. The first one is a study innovative techniques. The second one in attaching data and technology to improve viticulture, also with a big impact from meteorology. The third one is be responsible for maintaining and preserving complex ecosystem. And the fourth one, the last one is, and finally producing a product which is growing in popularity in terms of quality. Modern consumers are increasing concerned about the environmental and social impact of the product they buy, the wine. The demand of organic, biodynamic, and sustainable produced wine is growing really fast around the world. But the consuming is decreased, but this kind of really concept is growing really fast. In my vision, it's essential to strive for the highest possible level, especially in the field aligned with our own skills, field, and passion, because I think that the wine is really a passion for this planet. Only by doing so we establish ourselves as a stable authoritative benchmark with credible expertise and high reputation, considering current paradigm shift within the global economy, characterized by profound transformation on big turbulence across all levels and all sectors. It's a key point from my point of view in terms of knowledge for the future of our wonderful planet. In fact, agriculture have to approach in a total new way at the 360 degrees across innovation, technology, and meteorology. There are really interesting best case, for example, coming from California and US. I'm also an official California Sustainable Wine Growing Ambassador, and it's really clear that here there are many business case history and many great business study that lead the way. From my point of view, the final is really important to approach the matter with the new vision. In that for the first time, at least for us, we will approach this important field like following main categories. And the first one is sustainable business strategy, viticulture, soil management, water management, pest management, pest like Phylloxera, an historical famous parasite, wine quality, ecosystem management, energy efficiency, winery water conservation and quality, material handling, solid waste reduction and management, sustainable purchasing, human research, communication, because we implement also neuro-linguistic communication inside this course, neighbor and community, air quality and climate protection and meteorology. So you can understand that this is a new really approach with a new vision at the 360-degree vision. Holistic, I think. Holistic, I can say. So our target is a holistic approach to meteorology threats, that the atmosphere not as an isolated physical system, but as a deeply interconnected component of Earth's broader system, linked with physical science and with biology, human health, social behavior, and technology. This perspective moves beyond pure forecasting to understand the interaction of weather with ecosystems and society. That's all from my side. Thank you for this kind of opportunity to share in this new department approaching, and all the best and namaste. Thank you once again.
Thank you. Thank you so
Prof,
much,
did you
Professor
have
Mauro.
graphics for me?
Yeah, thank you so much, Professor Mauro. And yeah, we hope we will follow you how the meteorology will impact in the wine, especially in the wine production. Because in Nepal, also you heard now the agriculture, the farmer are focusing to make the wine from ginger and in the organic way. So later on, yeah, definitely we will in touch how we can collaborate with your university research department along with all the distinguished speakers. Now,
Thank you
now
so
we
much.
have
You also.
the last today's the last but not least the speaker. This is myself. So I'm going to present about our activities just like in 5 to 10 minutes, and then we will open the floor for the questions and answers. So please allow me to share my slide related to the meteorology and the activities what we are doing here in Nepal and across the globe. Thank you. Can you see my screen?
Yes.
Yeah, thank you. Yeah, I'm very much glad to organize this virtual event in collaboration with distinguished speakers, our partners, organization, academic institutions, and all the respected the experts who are here. Thank you so much. This is Pradeep Sapkota. I'm the founder director of SUNWay Research and Innovation Center, which is a social enterprise that initiates and promotes the use of ICT for education and agriculture innovation among the youth and farmers in rural communities in Nepal and across the globe. So the project highlight, we are in the phase of setting up the lab for the Research and Innovation Center. So this is the dream purpose lab where we made that AI animation video in collaboration with the student of Technical University of Eindhoven in the Netherlands, where the student did the internship at our research center in collaboration with One World Citizen Dutch organization. The founder is also here with us. And also on the project activities, we are also assembling the drone for agriculture, forest management, and the flood management. Also, we conduct the workshop to empower the youth, children, and the farmers from the rural area. And also, we developed the weather station and the dashboard app and the mobile app to monitor the real-time data, real-time environmental data, like the temperature, humidity, soil moisture, air pollution, pH, and so on. So that is what we developed here also, the automatic weather monitoring station here at our center in collaboration with our partners organization like One World Citizen and also with the Make Human Technology from Switzerland. Can you please mute your mic? Sorry. Also, we developed the automated smart greenhouse here at our center during the COVID time. Later on, in the next slide, I will show you the real how we are working. Also in the E-number, the robotics for seed planter, that is what we also developed as a prototype. Not like the same picture, but we made almost similar like that to drop the seed and also to water in the garden. So we developed that robotic irrigation as well. And our dream is also to working on the drone where they can carry the water or maybe the vitamins. Excuse me, please. Can you please mute your mic? Hello. Yeah, sorry. Also, we are also working on the rocket and drone development for the educational purpose. And his name is Sanjay from Delhi, from Dwarka. So I'm also collaborating with him since 2015. So the organization name called Space Development Nexus. Also, we are working on the drone, electric vehicle, and the Cube satellite. And this is the agriculture innovation here we developed in collaboration with One World Citizen and the Dutch city office, Den Bosch city office from the Netherlands. So here what we are developing, what we develop here is that we developed by using the local resources to develop the greenhouse, and also we assemble the sensors to monitor the real-time data inside the greenhouse as well as outside the greenhouse. And then by the connecting with the internet, so you can easily monitor through your mobile app. Also, we already made the mobile and the web app. So you can easily monitor what is happening inside the greenhouse as well as outside, not only in the greenhouse, anywhere you can install that devices. So this is the real, the greenhouse we developed, we constructed here during the COVID time. Yeah, funded by the One World Citizen and the One World Citizen organization and the Den Bosch city office from the Netherlands. And in the right side, you can see the sensors. So these are the low cost and the low tech devices where we can develop by yourself as well. Also, we made the course module, the e-learning module, so anyone can easily learn from there. So this is the mobile app. So through the mobile app, you can easily monitor the real-time data, and also you can control your irrigation pump and so on. During the COVID time, yeah, we planted the tomatoes over there, but it was really in the summertime. And inside the greenhouse, the temperature was around like 45 degrees Celsius, above 45 degrees Celsius during the summer, and I lost all the tomatoes. But the good lesson is that we need the cooling fan and the the cooling fan and the cooling pad to reduce the heating, right? But it is quite expensive to install on that one small greenhouse. But we are also looking some partners, how we can scale up those kind of the technology and to empower and educate the youngsters towards the food security. Also from the device, what we monitor, you can easily monitor through the web app in the graph. So in the graphical format, the data will fluctuate and you can see what is happening over there. Also, at the same time, you can also monitor from the mobile app. Also, I love to work with the stuffs, what we find surrounding the home area, because we are focusing and we are talking about the sustainability. But in my views, if we don't focus on the local resources, what we have in the surrounding, then there is not any meaning of sustainability. So that's why we managed to get the damaged bike and we made like that tools by welding and grinding at our center. And also another interesting thing, through the LoRa technology, we developed the weather monitoring devices. So, yeah, it is a bit, I don't know who. Yes, I think now, yeah, the mic is muted, sorry. Yeah. So from that device, we don't need the electricity and the Wi-Fi. By saying that, in the agriculture field, there is no electricity and no Wi-Fi. But if you want to get the data, then how you can get the data? Either you can have to go there manually, or you need the electricity or the Wi-Fi over there to get the data. But by using the LoRa technology, in between 5 to 10 kilometers, we can get the data from the sender, where the picture A is the sender where we install at the agriculture field, and the B is the receiver device where the data received from sender, and then the B device is connected with the internet, and then the data sends to the cloud, and then you can monitor through the mobile or the web app. So in that way, we made here the complete system devices over here. And also we conduct the training and workshop to the youth and the farmers. So this is the prototype of the LoRa device. And this is our small lab here. We worked, we developed the LoRa devices, and also we installed in the 4 different places during the COVID time. So from the 4 different coordinates, we can get the data, the real-time data in the same web platform in the single page. Also at the reforestation, also we use that in the forest. Yeah, and also we were invited through the One World Citizen and the partner organization in the Switzerland in 2022. Also, we got the second prize award. And then again, we went to the Vienna after that. So by saying that we are a bit unique, why? Because we are focusing on the vocational training, research and development, and focusing to integrate those technology for the own food production. And also we are working on the smart food forest. So these are our partners, and now we are also looking at the partners like you all across the globe. This is my presentation, and now I'm going to just show you the devices. So this is the LoRa device. So this device has multiple sensors, like the weather monitor, like the temperature and humidity sensor. And also we have here other the devices with the multiple sensor, like this is the temperature, humidity sensor. This is the soil moisture sensor. And we have other sensor inside here to measure the light intensity as well as the air quality. And also we have another sensor which measures the soil temperature. So that means we develop here, and also we conduct the trainings, and we provide the technology towards the people from one country to another country. So that is what we are doing in collaboration with like you all. Yeah, thank you so much. Yeah, and now I'd like to invite our moderator, Pastor Ruben, to moderate this event where I see lots of the questions and also the curiosities to our distinguished speakers from the participants. Floor is now on your head. Please, thank you.
Thank you, Professor. That was really a blessing, and to okay. For those who arrived today to meet with us in here, this is very informative. I want to find out before we ask questions. We're meeting tomorrow at the same time, is it? Prof?
Yeah, tomorrow we will start at the same time. So I'd like to request you, it's my humble request to join at the exact time, because tomorrow we have the 8 speakers. Thank you.
Okay, but the whole process being recorded, is that so?
Yeah, it is recorded, yeah.
We recorded, okay, wonderful. So since it is recorded, we may take a few minutes just to find out few people who have got questions. If you have got questions, please, you can raise your hand and then we acknowledge you. Looks like we are all satisfied with the presentation. And those who did the presentation, do we have your website?
Yeah, we have the hand from Colette. Yeah, please. I see the hand.
Please, Paulette, yeah. Go ahead.
Great. Thank you, gentlemen. What a wonderful conference this has been. So much great information has been shared. But I have 2 questions, one for Dr. Akhilesh from India. I would be curious about your insights on the Caribbean region, because that is where I sit right now. and your insights on Latin America. Though they covered Guyana and Suriname, I didn't see much information about the Caribbean. So if you'd like to share that separately, I'd be happy to review, but I'm curious about that information. And secondly, I wanted to reach out to Richard Nelson. And Richard is an old friend of mine. Actually, I'm the person that he's connected with in the Caribbean region in Trinidad and Tobago. So I was quite pleased to see you here. So I wanted to know about your interest as far as the region goes, because what you shared can also impact greatly the movement in the Caribbean region for the schools that are already in operation. So I would leave that there. Thank you again, gentlemen and ladies, for this opportunity. Thank you.
Yeah,
Well,
also,
just quickly say that we're very interested with this small life pod. It's actually designed for STEM programs. And, there's at least 6 schools now looking at, incorporating one of these projects as a learning by doing, and also, of course, innovation aspect to teaching. So I'd be happy to follow up with you about that.
Thank you very much. We have several schools that are part of the movement already, so I'd be happy to discuss it more. Thanks, sir.
Who was next?
yeah,
Hey,
Sanjay
one quick
Bhatta.
question. This is Calvin in the US. I'm absolutely amazed by all the projects and all the work that you guys are doing. Pradeep, I hope that you could share everybody's contact after the conference.
Yeah, sure, I will.
Because I would love
I will add on the WhatsApp group to you all. Yeah.
Okay, and my other question, I guess you may not have an answer now. I love this platform, but I would love for this be to face sometime in the near future, and maybe we can do this in the US sometime in the future, face to face. So I'll offer up an invitation for you guys to come visit us in Illinois.
Thank you.
Oh, maybe I'll invite everybody to South Africa.
Either way, love it.
Yeah.
And everybody to the Caribbean.
Yeah. Also, because of the timing, we just have like 5 minutes remaining. To end this session. So I'm very much extremely sorry because of the timing. Yeah, I see the 2 participants have the questions. Yeah, the Sanjay and Mohammad Nura from Nigeria.
Okay, so I'd like to take the floor. I'm Sanjoy Chandra Bhattacharjee from Bangladesh. So I'll be delivering my speech tomorrow. So today, I'm very much happy to see the system LoRa. So I'd be suggesting, I'd be working with you, Pradipta, how we can maximize this device for zero tillage system fodder production for livestock. I think that would be really game changing for the agro ecosystem in agro ecosystem for developing agro ecosystems in Bangladesh as well, because people are sequestering, as people are more aware now in carbon sequestration. So this device could help very much to determine the approximate soil condition for zero tillage system. So are you working, or do you have an intention to extend your device on that case as well?
Yes, sure. Definitely, we can do that. Definitely. Yeah. After this event, we will keep in touch how we can make it more actionable. So that's why we are organizing this event. So thank you so much.
Thank you.
And also, I see,
good afternoon.
Nura.
It has been very interesting meeting and a lot of enlightening educative and eye-opening contributions from our professors and doctors. I am more interested in the presentation of Professor Richard Nelson. And why is because the catching point is that consumers can become producers. So how we can really encourage that because of the space it could occupy to be able to be a contributive and also grow in it in our community. So I want to push this technology in my community and how we can go about it and how we're able to develop it so that it could have a wider reach. At least let's start small and grow in it. So thank you very much and hoping to hear from you in the next forum.
Yeah, just quickly.
So how do we reach out to you, sir?
Well, we do. I posted my website and my email. Plus, I think on the chat, the WhatsApp, we can all connect. And thank you, Pradeep, for making this all possible. We do envision Fab Labs, community-based, open source places where. And it can be at schools, oftentimes, but it can be also community enterprise, right? Community enterprise incubators and for these kind of constructions that are pretty much a DIY, So it's really a knowledge-based program. The materials and such are not exotic in any way, so everyone can do it. Thank you.
Wonderful.
Yeah, now I see the hand from Marcus.
Yeah, the same question to Richard, because that's a really fascinating project, the LivePod. Has any LivePod been built, and are the plans already available open source somewhere? So I can use the local Fab Lab here to build one?
Yes, I think that would work quite well. So what we've done is we've been bringing this to a small scale. So actually, the LifePod is in itself a prototype, but the technology is already very well proven for decades. And but what we need to do is, bring this sort of to the people. And so that's become the project for the last maybe 3 years or so. So we do have preliminary prototypes. We're now looking at getting production underway, sort of replicable, systems. And I think as an open source project, then of course, success can be replicated with many groups working on the same, problem, so to speak, right? It's not really, I would put it that way, working on the same solution. That's a better way to put it.
But has anything been built already?
Oh, yes. There's quite a bit of work, I mean, at a more advanced stage, actually, in China. So my partner, you'll notice that our website is bilingual in Mandarin. And so, yeah, you can see there, especially. I'm in Canada, and most of all of this work has happened in other countries since quite a while, not Canada.
Which website is this? Did you share it already?
Yes, it's a Pyrapod. I'll just put it again in the general chat, so anyone can just click on that and you'll go there. I'll put it there right now. Message to everyone.
Amazing work. So thank you.
I'll give you the reference for the page. How does it work? Because that's a nice place to start. Yeah, there, I put it up. Can everyone see it? I think so.
We will check it. The program is being recorded, so please don't throw away the record. Or if you don't have the recording, quote me or Professor Pradas, we then give it to everybody. Thank you so much. I think we have got a few minutes. Professor, how much time do we have?
Yeah. Time is almost done, but yeah, we have time. Let's say like 5 to 10 minutes. Then we are going to wrap up. Before that, also, yeah, I'd like to invite the founder director of One World Citizen, Monique Vandam, to share her thoughts, because since a long time I'm working with her since 2012 or 13. Yeah. So
Okay, thank you,
yeah,
Pradeep.
please.
I'm not prepared, so I do something from the heart, yeah,
No,
like
just
everything.
what you see from that perspective. Yeah, thank you. Yeah.
Yes, yeah, yeah. As you can see in my name, we started One World Citizens as a foundation in 2012 with the first group of young people, because we saw we need the vision and ideas of the youngest generations to build a future. And we also opened our Facebook page. And Pradeep was one of the first young people from outside Europe, let's say. So I'm from the Netherlands, who knocked on the door and he said, I'm also a One World citizen. And then we started communication, and he was very clear already with the need of non-formal education on ICT and later technology. In his case, on agriculture and food security. But also other young people knocked on the door. And by that, we were able to build a community in 12, 13 years under the name of We Grow Together, in which we have more young people like Pradeep. And they show it makes sense to facilitate young people with the ideas for change in their local communities. And we focused on basic needs for all, but also making work of basic needs, so that more and more they are independent from grants and donations. And that's where we are now. We are now in a phase after 13 years with young people from 20 countries that we see, yeah, it works. Young people help each other to turn ideas into projects or startups, but also they are willing to train other young people in the thing they developed. So yeah, in one word, it's very hopeful. And maybe this is enough for today, Pradeep. Maybe tomorrow I'll say something else.
Thank you.
Thank you for
Wonderful.
organizing this anyway.
Thank you so much. Yeah, before
You're
we,
welcome.
Wonderful.
yeah, before we invite
Professor,
our
did my brother from Malawi arrive? Or
yeah,
he didn't come?
yeah, I'm inviting him. So before we invite,
But did he come in?
Yeah, he's there. Yeah, I see he was there. Professor Osman. Yes. So before I invite,
Let him say.
yeah, I'd like to invite Professor Dr. Osman. He is the Chancellor and the President of the Central Christian University, Moloi, where our research center and the Moloi, we did the MOU as well. So CCU is our academic partner with the research center, SUNWay Research Center. So please, I would like to welcome this event's chairperson, Professor Dr. Osman. Thank you, please. The floor is yours.
Thank you very much, Mr. Host, Professor. For organizing this wonderful event. First of all, let me greet each and everyone, the great scientists, experts who have gathered in this forum to share one or two, three things which are really a big concern for our continent, I mean for our world. Issue of climate change has been discussed at length by various presenters, and how we can fix those challenges. That's very encouraging. And now we're going to see we are now trying to rethink. Instead of going to the moon, now we are coming back into our world to fix the problems which we are facing now in our continents, be in Africa, Europe, Asia, yeah, in North and South America. These are the challenges which we are facing related to climate change. So we need to see scientists now to rethink instead of going to the moon, now we fix these problems in relation to issue of sustainability for us and for the future generation. So I'm really fascinated in the way how the presentations have been flowing. A lot of innovations, the technological ideas has been shared. So we need to see these ideas trickling down to the vulnerable people in our communities. So Mr. Director and the founder of SUNWay Research and Innovation Center will make sure that these ideas which has been discussed here, has been shared here, should not get lost or get lying idle in your office. Mr. Director, make sure that we need to share this so that we support our people in our communities. The first session has been very good, very organized, and I think tomorrow we are going to enjoy more as the other new presenters will be bringing in with their innovations and ideas on how we can tackle issues of climate change. And again, there have been a contest there, Prof. there, Ruben, as a coordinator. Thank you for the wonderful job you have done, coordinate this event. And the host, thank you for a wonderful event in the first day. And tomorrow, I think you have more, as I said. So with these few remarks, I would like to thank all participants, presenters, our experts, our scientists, which has spared their time to share with us what they have in order to help us to think and support our communities in fight against climate change. Thank you very much.
Thank you. Thank you so much.
Thank you, Prof. Before the computer throws us away, we started with prayer. We're still going to close with a prayer. And then, please, I encourage everybody, read the recorded information there. And
excuse me,
is our done?
Ruben, Pastor Ruben.
Do we still have time?
Yeah, we have, because I'm inviting the vote for the vote of thanks. So before we end, I invite you, Pastor Ruben, for the prayers. Okay. So, well, first of all, thank you so much, Professor Osman, for your wonderful the ideas and also the thoughts what we are doing. And I'm sure the Central Christian University will collaborate with us in these global activities, all together with the distinguished experts, scientists from different corners of the world towards the peace and development. So thank you so much for your welcoming to join and to collaborate with you all. Now, it is now my privilege to invite our respected vote of thanks speaker, Ambassador Colette, to deliver the vote of thanks. Respected Ambassador Colette, may I kindly request you to present the vote of thanks. The platform is now yours, please. Thank you.
Thank you. Thank you. Again, my name is Colette Cyrus Burnett, and I am the founder of the Global Food Warrior Movement. It is that I have the pleasure of working with Ambassador Pradeep on making sure that our children have food to eat. So I'm grateful to be here to say thank you to our speakers, specifically beginning with Professor Clyde Phillip, who talked about our ability to impact change. And his regional leadership in the Caribbean and Latin America has been such huge impact, from opening the doors that are there and necessary to be opened for the voice of our young people. And I cannot tell him thank you enough for all that he has been doing as far as it goes for food security and for his work in engineering. We also had Professor Ugoji from the USA, who spoke on collaboration and data sharing, and how important it is that our early warning systems empower our communities for climate resilience. couldn't be more grateful to have her voice on here today. We also heard from Ivan Matusek, who is the chairman of Water for Climate. And his NGO has been focusing on sensors for monitoring how much water is being used for our most important works like food and agriculture. As you know, all of us really do need to eat, and for our global wellness. So couldn't be more important as well. Thank you, Ivan. We have been also hearing from Dr. Patrick from Romania, the meteorological data for weather forecasting for agriculture, tourism, urban planning, that you joined us in this and from that most isolated peak. Tells a lot about your commitment, sir, and we appreciate you coming in and your presence here from Romania. Dr. Richard Nelson, inventor from Canada, your climate adaptation, close control ecosystems for plant growth, really, it helps us all. And we consider your life pod and life farm low-tech systems to be really that which is necessary for our families to continue to subsist. So thank you for your work there. Transforming a consumer from a producer. That's one of the notes that I took for us to take us forward, because every single one of us on here understand what that means for individual sovereignty, of course, but also for the world at large. So thank you for that, and thank you for your work. We heard after that from Dr. Akesh from Astreep, chairman of the group for in India, scientists. Your monitoring of the climate to address the changes at the core cannot be overstated. Having direct data to support what we can feel and already know is key. So bringing about sustainable solutions. Thank you for your work. Thank you for you connecting with us today. I expect that there will be much more work that we can do together. Then we heard from Marcus Ledway from Partech. His scientific data collection and hyperlocal data and open source sensor for air quality can't also be overstated, because, well, we definitely need to breathe. So thank you for that, because it also allows us to be able to see that work throughout the world. And it isn't hard to see how it would be able to be done on our bus systems in every city. So thank you. And then we heard from Lopata Losif for the cloud seeding for use in agriculture and climate changes. Hail suppression is key to protecting our high value crops. And for agricultural risk management, we are grateful for your work. And we can see how it will help all of the world as we continue forward. We heard from Professor Muro from Italy. Your 360 vision on using the data for impact agriculture and how it intertwines with the business of wine and its correlation to meteorological data for use in science cannot help us better predict the impact. So your vision on that ecosystem and how it moves the global economy was a pleasure to learn about. It was the first time I thought about wine from that level. So thank you for that. Ambassador Pradeep, I can't tell you thank you enough, because this 2 hours that we've spent together, I've learned more in it, hearing directly from these experts, and then hearing from you on monitoring the weather, your robotic seed planters, and your automated smart garden greenhouse. Your work on research is what has brought us all together here. And for this monumental sacrifice and for this particular conference, your influence in impacting world change cannot be overstated. Thank you for this and for all of your work, Ambassador. I can't tell you thank you enough. Dr. Monique, your work in One World Citizen has come across my desk several times. Your work with young people in particular is something that is outstanding. So I can't wait to hear from you tomorrow as well. Thank you for what you shared today. And finally, Dr. Osman, thank you for addressing the team and for addressing our most pressing challenges due to climate change. Today is just one of the 2 days that I know will change all of our lives. So I get to say thank you to each one of you, but I want to say it from my own heart to you. Your work and what you have done thus far is extremely important to how our world goes forward. So Thank you, thank you, thank you, and thank you for the opportunity.
Thank you. Thank you so much, Ambassador Colette. By wrapping up all these almost the 3 hours event in a short summary and the gist, really that opens again and also energize the body for the tomorrow's event. Not only that, also to keep continuing and to follow up with all the distinguished participants, speakers, experts across the globe. So we are almost in the ending session. So Pastor Ruben, are you there? I think he is gone. Okay. So, well, yeah, now we are on the move to the formal closing of this session. So, dear distinguished dignitaries, respected speakers, honor participants, ladies and gentlemen, on the behalf of SUNWay Research and Innovation Center and all our partners organizations, we extend our sincere gratitude to each one of you for your esteemed presence and valuable participants with your fantastic presentation in this World Meteorological Day virtually conducted under the theme Observing Today and Protecting Tomorrow. Definitely today we observe a lot of things from the different countries, how our experts, how our researchers, practitioners are doing, working day and night, and towards to protect for tomorrows, that means in the coming generations. Your insights, cooperation, and commitment to advancing meteorological knowledge and environmental sustainability are deeply appreciated. We look forward to your continued collaboration and participants in our future academic and scientific initiatives. I would like to thank you once again with sincere appreciation. I declare today's session is formally concluded, and also tomorrow I would like to humbly request you all to be in the time by which we can hear from our 8 speakers. They are also working on very diverse topics, so that is also very interesting. So I hope you will enjoy. So I wish you all very good evening, good night, good morning, good afternoon. Thank you so much for all your time, consideration, and participants. Thank you so much. Namaste. Bye.
Bye, everybody.
Okay, bye.
Bye.
See you tomorrow.
See you tomorrow.
Yeah. See
Bye,
you
Monique.
tomorrow.
Bye.
So yeah, of course I will record this video and then I will upload on the YouTube. Yeah, I will follow. I will send the link later on. Thank you.